Hello everyone, my name is George, and today we're going to be diving into what makes your computer tick. We're going to look at CPU cores, threads, hyperthreading, and why GPUs even exist at all. By the end of this video, you'll know exactly how many cores you're going to need for your applications and why they matter, and when to call in for that GPU. So let's get into it. If you've ever taken an introductory course in computer science, you're told that the CPU is the brain of the computer. But what does that even mean? The CPU means central processing unit, and quite literally, it is the brain of the computer. So every decision, every calculation, every logical operation flows through it, just like our brain processes thoughts and decision making. So what are CPU cores? So think of cores like ridges on a farm. So more ridges mean you can plant more rows at the same time, and you can also harvest more at the same time. So same for CPU cores and simultaneous tasks. The more CPU cores you have, the more tasks you can take on at the same time. So higher computational tasks may require much more CPU cores, while less computational tasks will require much less CPU. Dual core or quad core? Let's go back a few years. No one was talking about GPUs, and if you wanted to buy a computer, you were mostly concerned on whether it's a dual core or quad core. A dual core meant it had 2 processing units, so 2 cores, while a quad core meant that it had 4 processing units. Now quad obviously performs much better, but only when software can split work across those cores. Hyperthreading. Hyperthreading is a technology that's supported by some CPUs like Intel's and AMD SMT. It allows a single core in a CPU to work on multiple tasks at the same time. And this is achieved by simulating virtual cores, so it makes a single CPU work like multiple cores. So by juggling 2 instruction streams, it's keeping its functional units busy, which is great for throughput workloads and applications that support parallel processing. Now, they are also known as logical cores, so while they kind of help improve the performance in some applications, they are not as powerful as physical cores. Now keep in mind that during hyperthreading, we are still sharing the same cache memory, registers, and execution units between the 2 concurrent application threads. So what is multithreading? So think of threading from the concept of an application. So threads are like mini processes inside a program. They share memory, so switching between them is cheap, so letting the CPU stay busy. And threads are like virtual sequences of instructions originating from the same parent process. High-performance intensive applications like 3D animation and video editing led to huge performance issues on the CPUs. The CPU struggled with such workloads, and as a result, the GPU was born. So the GPUs have many simpler cores, each of these cores much weaker than the CPU core, but together lightning fast at parallel work. So shocker for you here might be to learn that GPU cores are actually less powerful than CPU cores. GPUs excel at parallel processing due to having thousands of cores, and as such, they are well suited for applications that have these high demands for parallel processing. So what's the difference between a CPU and a GPU? I love this analogy from Amazon AWS, which perfectly describes, in my opinion, the difference between a CPU and a GPU. And it says that the CPU is like a head chef in a large restaurant. It has to make sure hundreds of burgers get flipped. Even if the head chef can do it personally, it's not the best use of their time. All kitchen operations may halt or slow down while the head chef is completing this simple but time-consuming task. So to avoid this, the head chef can use junior assistants who flip several burgers in parallel. The GPU is more like a junior assistant with 10 hands who can flip burgers in 10 seconds. So as a result, GPUs are much more suited for high-performance computing tasks and deep learning. So while having more cores often means more performance and processing, it's not all rosy. There are downsides to having more cores as well. Extra cores draw extra watts, so you need more power. And if your software is single-threaded, then those extra cores just sit idle. So it's always very important to match the hardware to the workload that you want to run on it. So in conclusion, CPU cores handle much more general tasks. Threads let software take advantage of those extra cores. Hyperthreading adds logical cores. GPUs crush massively parallel jobs. And finally, having the right mix of the right tools ensures you achieve maximum performance for your workloads per watt. So that's it for this video. Make sure to hit the like and subscribe button if you haven't. Please subscribe if you want to keep seeing videos like this, and I'll see you guys in the next one. Bye for now.